Welcome back. We continue our discussion on online auctions. In fact, we started before see what are online auctions are. They are just the online counterpart of general auctions. So, what we have been doing since past 2 lectures is that we are trying to understand that auction is a market mechanism, a price discovery mechanism, and it is one of the dynamic pricing mechanism. It helps in price differentiation, and that price differentiation is actually first degree price differentiation, where every product will have different valuation for a buyer depending on the market condition. Then in the subsequent classes, in the just previous class, we learned about how to differentiate between various auction types, and we saw that auctions can be classified in many ways based on the resource that is being auctioned, based on the payment rule and so on. Now, today we are going to consider what are various economic consideration under auction. So, in this lecture we are going to learn about auction design problem and try to understand what is the difference between efficiency and optimality consideration during design. And we are going to see one example of one auction mechanism, how a auction mechanism design happen. So, when we talk about auction design problem, it is, first of all let me tell you, it is a strategic level problem. By strategic level we mean, here decision has to be made what kind of auction is to be conducted and what should be the general rules for conducting that auction. In economic literature, while modeling auction mechanisms, while designing auction mechanism and modeling the bidding behavior etc., auction is considered as a game, and game theoretic analysis is done to find out the equilibrium point. You need not have to worry that you have to learn now game theory, because I am not going to teach game theory, but in a very simple manner I will be explaining how what is the meaning of auction design and how important it is. In fact, in the very first lecture I was showing one example of a spectrum auction which happened probably in New Zealand, where what happened, due to bad design, they designed what they did, they designed a second price auction, a Bikre auction. So, what is Bikre auction? Bikre auction is a situation in which the highest bidder gets the item, but at the second highest bidder's price. So, in that particular auction, in that particular spectrum auction, New Zealand spectrum auction, what happened? Theoretically these second price auctions are very good, but what happened at that point of time during actual real auction, the first bidder's value was very high and second bidder's value it was in hundreds, probably in millions or so, and second bidder's was in hundreds. I do not remember the exact picture. Exact figures, you can see the previous slide to see the figures, but what happened as a result, due to bad design, the government now has to, because what government decided the rule? Government decided the rule as the highest bidder will get the item, but at the second highest bidder's price. So, even if the second highest bidder's price was very low, because of the originally declared rule, the government has to give the highest bidder at that price. Now, what is the benefit of the second price auction etc., that we are shortly going to discuss, is not known to everybody. Only economists know that it has many beautiful properties, but it became a political issue that government is trying to do something, so that at a very low price the spectrum is getting auctioned. As a result, that particular auction was made null and void, and with a better designed rule the country went for spectrum auction once again. However, today we are not, I mean these are the the auction design is what the point that I am going to make is the auction design is that important anyway, but right now we are not going in depth into the design, but we will be getting an overview of how important the design problem is and see one example of specifically that second price auction that I was telling about, like why this second price auction is good, that we are going to look at. Now, this auction design problem is about deciding the rules with certain desirable outcome that satisfy the auctioneer's need. So, this design involves modeling preferences, behavior, information available to the agent and so on. Now, designing mechanisms in which the agent strategies result into outcome with the desirable property, that mechanism is chosen out of many available mechanisms. Now, during this design process, the first task is to model the bidder's valuation behavior. How exactly bidder evaluate the product under consideration. There are 3 types of model in this category. In the first one is the private value model. This is applicable to the situations where each bidder's valuation is different from the other. Now, consider a situation, some antique is getting sold, it is very valuable, its price is very high. A rich person may try to give a very high, let us say $1 million for that. However, given this $1 million to me, definitely I will not be paying that much money for the antique. The point that I am going to make is that that rich person and me, both of them are bidding for the same item, but my valuation of that item is different from that of the rich person, the other person. So, which means depending on my background, my economic condition and my requirement of the product, because antique is something which I may not need, I may not have might not have fulfilled many of my basic needs as well. So, therefore, the item under consideration that is in this case the antique is not that important in my life. So, I would be paying, my valuation of the antique will be very less. So, this is if you have a situation of this type where individual bidders have their everybody has a potentially different valuation for the good under consideration, then it comes under this private value model. Now, this private value model again it can be for symmetric, it can be symmetric or asymmetric. In case of symmetric, all the bidders draw their valuation from a common distribution. By this we mean that the bidders who are participating, it is a let us say all the rich people, the many rich people, 10 rich people let us say, who have interest for collecting these antiques, all of them are bidding in this. So, possibly all their valuations will come within certain range, okay? Or in other words we can say they all of them are going to draw their valuation from a common distribution. But the case that I was considering already, that myself and let us say that rich fellow, in that case our valuations are, we have asymmetric valuations. So, the model can be for symmetric or asymmetric valuation. The next one is your common value model. In case of common value model, the good in the question which is getting sold using auction has same valuation. So, for this one try to consider one example that in fact, in the very first class on auctions I told you how what was the push for developing this auction theory. That time around 1970s, the US government made an auction of the oil fields possible, I mean the for oil exploration right, it tried auctioning the oil exploration right in its shore. Possibly in this situation, the companies who will be bidding, somehow they estimate the amount of oil available in those areas. So, naturally their valuation for that oil for bidding for that oil exploration right will be almost same. So, this is called common value model. All of them, all the bidders are of equal of similar background, all of them have equal interest on the object and they have same valuation for the object. Okay. Now, next is your interdependent model. In case of interdependent model, let us take one example of a laptop which is getting sold on auction in eBay. So, that laptop which you need and let us say some few other bidders need, it is after all a old laptop. We would like to buy it as cheap as possible, is not it? And there will be competition among us to buy that laptop. Now, from the beginning I will have just an estimate, because it is a very old make, features are old, I will have just some estimate about its price and I bid accordingly. As I get price signals from others, by price signal mean when others bid and I come to know that my valuation is indeed not right, and probably because from others price signal I will be estimating, re-estimating my valuation, I will be thinking probably the value of the item is little bit more. So, accordingly I will start increasing my bid. So, in such situation we the bidding behavior is modeled as a interdependent value model. So, here each bidder has only an estimate regarding the value. This estimate may change after getting the price signal from the other. This is what I was telling you. Now, while designing auction mechanism, what is mechanism? Mechanism is about deciding the rule of the game. Auction is considered as a game. Who are the players? Players are the bidders and the auctioneer, of course. So, these bidders will be competing with themselves to increase or decrease the price depending on the situation. When they will increase the price, in case of a forward auction, they which is a selling auction, they will be competing with each other to increase the price, so that the highest bidder gets the item. And when they will be decreasing the price, if it is a reverse auction, a buying auction, they will start at a high price and they will compete among themselves to decrease the price. So, whatever so in this situation there are two important design goals. Either the auction has to be Pareto efficient or auction has to be profit maximizing. Now, what is Pareto efficiency? Pareto efficiency is about design of an auction that results in a Pareto efficient outcome. By Pareto efficient outcome we mean after the transaction is over, in this case the auction, Pareto efficiency is not the properties of auction only, it can be auction of any economic, it can be property of any economic transaction. So, any economic transaction is Pareto efficient if after the transaction is over, no further trade is possible in the market. Okay. So, which means the item has to go to that person who needs it most. Now, how do I know the person who needs it most? The person who will be paying the highest. At what signal do I have? I have only the price signal. So, I will be choosing that person who will be giving me the highest price. I will think that he is the most needy person. Now, the question is it so? If I declare from the beginning that the item will be going to the person who is providing me the highest price, people may try to give certain false valuation of the item, false bids. So, in that case, I may not get the right price signal from the market. Now, consider a situation, what is the, how after trade can happen in this case. Look, let us say government is making has made some apartments in various places within a city, and it is selling those apartments, and it has decided a very a good price for the apartment, and it is trying to let us say conduct it is just first come first served basis. So, what will happen? It will try getting applications, price is fixed based on first come first served basis, the flats will be allocated. Other preference of the buyer will not be considered. Now, suppose I have some I have 50 lakh rupees with me to buy the apartment, and the price set by government is let us say 40 lakh rupees, and I in the lottery or in the first come first served basis, I got a home allotted to me, which is quite far off from my office, and I know another person who has got a house, got an apartment under this scheme, whose apartment is near my office. Now, I would like to exchange my apartment with the other person, unless otherwise there is some government restriction. So, what do I do now? The extra money that I had as my earlier initial estimate of buying the flat, that is 50 lakh rupees, I have 10 lakh rupees left with me. So, what will I do? I will be giving that money, offering that money to the other person whose apartment is near my office, and try to exchange it. So, in this market, after this is over, exchange is possible. Now, think of auction. In case of auction, if individually for each flat auction goes on, then for the apartment which is near my office, I will be paying the highest value probably, and after getting the item, I will not go for further transaction in the market. In fact, everybody depending on their own convenience, they will be going for auctions in their specific locations. Okay. Now, the situation is bit problematic here as well. If the auction is going on, it may so happen somebody else, because nobody will be revealing how much money they truly have to spend. So, what they will be doing? They will be trying to hide some of their money. Now, if some benefit is given to reveal their valuation, then everybody will do so. So, here comes the use of second price auction. In second price auction, if I am told that whatever I may bid, if I am the highest bidder, then I have to pay the second highest bidder's price. So, in that case, I will be revealing my true valuation. In the auction, in the first price auction, probably I could have gone, depending on my competitors, I could have gone up to, let us say 45 lakhs or something, but there, because I know I have to pay the second bidder's price, I will be revealing that I will pay 50 lakh rupees. So, also others. So, truly the way I was hiding my price, others might be also be hiding their price. So, now everybody will be revealing their valuation. So, if everybody reveals their valuation, we know that who is the most needed person, who is willing to, whose valuation of the item is the highest because he needs it. So, whose valuation is the highest, because everybody reveals their valuation now, the item will go to the person with highest valuation, but with the second highest price. So, the amount which he bids and which he pays, there is a difference. So, he got some benefit, he got whatever he was prepared to pay, he got it at a little less price. So, therefore, he will be assured and tell his valuation from the beginning. Then, second one is the profit maximization. In case of profit maximization, the aim is to design the auction which yields the highest expected profit to the seller or minimizes the cost of the buyer. Now, the item should go to the person who pays the highest amount. He may not be the most needed person to get the item. By most needed, we mean we need not bother what is the right valuation of the person. In the first case, we were actually bothered what is the right valuation of the person, but here it is not. Now, coming to efficiency versus optimality, different situations demand efficient auction and some other situations demand optimal auction. For example, optimal auctions are designed to maximize the expected revenue of the seller by using a set of tools including posing a reservation price or charging an entry fee, whereas objective of the efficient auction is to maximize the social welfare, the sum of the players' surplus. Efficient auction design aims to maximize the system welfare, I mean everybody is benefited and the system as a whole is benefited, whereas the optimal design aims to maximize the seller's individual revenue. In case of again going further, this optimality and efficiency usually cannot be achieved simultaneously. So, therefore, the auction designer has to make the choice before he states the rule of the auction. Usually, the financially self-interested agents like that of business houses etc., they prefer optimal auctions, while a public agent like that of government may prefer an efficient auction to gain more social welfare. Anyway, so most agents anyway try to balance their optimality and efficiency to make the auctions practical. Okay. Now, when we consider three popular auction mechanisms like first price auction, second price auction and English auction, in a very simple format, like you have a single buyer and you have a single you have a single in case of a reverse auction you have a single buyer and many sellers. In case of a forward auction you have a one seller and many buyers. So, in this situation, if a single object is getting sold or bought single object, single unit of single object, all the major auction format are efficient assuming that the bidder is truthful. Now, assuming the bidder is truthful is again a little bit stringent condition. How do I know the bidders are truthful? We are going to shortly to see that the second price auction that or the victory auction that I was talking about so far indeed enforces the bidders to be truthful. Will a rough kind of proof we are going to see. Then next is your optimality. The first price and English auctions are optimal. Second price auction becomes optimal if an appropriate reserve price is set. Okay. Now, as I was telling you, while modeling the auction mechanism, auction is considered as a game. In fact, it is considered as a Bayesian game, because the exact bidding value of the bid value of the bidders is not known. Here the bidders are the players. The problem is to find out the equilibrium from which nobody can deviate. In fact, in all the game theoretic problem, the problem is to find out the equilibrium point from which nobody can deviate. So, we have to now formulate the model to find out how to make the efficient allocation. There are many basic assumptions in the model. There are some n number of bidders. All the bidders values are independent and identically distributed random variable. They are symmetric and they independently draw their valuation. Bidders are risk neutral. In fact, about risk neutrality we did not discuss. When it considers the bidding behavior, a bidder can be risk neutral or risk averse or risk lover. In case of risk averse, in case there is more risk, he would not like the situation. In case of risk loving environment, risk loving bidders, in case there is a environment where the bidder has to take risk, he will love it. And in case of risk neutral, he is indifferent between taking risk or not taking risk. And again another assumption is the bidders themselves show no collusion or predatory behavior. By collusion we mean the bidders themselves are not colluded with themselves and somehow control the market. Now, under this assumption all the basic auction formats are efficient and generate same revenue. This particular result is a very important result called revenue equivalence theorem. Now, let us look at the example of a bidding strategy in second price auction, because we are not going to have a very the elaborate discussion on how to design auctions. Rather, we will see that what is the meaning of a auction design. See, so far we have been telling that the auction, it is one of the basic assumption is the bidders truthfully reveal their bid. Now, what is the guarantee that they will truthfully reveal their bid? Now, we are going to see a situation where the bidders, even if without you directly stating, because of the rule of the auction, they will be compelled to truthfully bid, and that is why this is supposed to be a very good property. Okay. Now, look at this, why they will be bidding. We are considering a very simple case of two bidders. Let their valuation for the object be V1 and V2. Now, let the bidders bid the values B1 and B2. Now, what is the difference between valuation and bid value? Let us say, let us consider about that apartment example again. My valuation of the apartment is 50 lakh rupees, but while placing the bid, I will be little cautious. Why to reveal my bid, reveal my true valuation? I will be bidding 40 lakh rupees only to start with, or maybe 30 lakh rupees to start with. So, there is a difference between what I bid and what I value. So, in case of forward auction, my valuation will be more than my bid value. In case of reverse auction, my valuation will be less than my bid value. Now, what is my expected payoff? First of all, what is my payoff? What after winning this auction, what am I going to get? I am going to get V 1 minus B 1 if I am the first bidder. My valuation is V 50 lakh rupees, my bid is 40 lakh rupees. If I win, I am going to save 10 lakh rupees. Now, what is the guarantee that I am going to win? That is a chance event. So, my probability of winning is actually the probability that my bid is higher than the other person's bid. So, this probability of B 1 minus B 1 greater than equal to B 2, B 1 is my bid is greater than equal to B 2 into B 1 my B 2. So, my expected payoff which is evaluated, which based on which I will be deciding my bidding strategy, because bidding is not yet over. So, it is ex post, it is before. So, probability of B 1 greater than equal to B 2 into B 1 minus B 2. Okay. Okay. So, look, actually we are considering about the second price auction. So, if it would have been first price auction, my benefit would have been V 1 minus B 1, but the second price auction tells me that I will be getting the item at the second bidder's price. So, the benefit that I am going to get is V 1 minus B 2. So, my payoff, my expected payoff is probability of my winning into my valuation by the other person's bid. Now, let us try to figure out under this situation whether I will be truthfully bidding or not. Now, look, if V 1 is greater than B 2, I mean truly my valuation is greater than the other person's bid value, then in order to win, I will make B 1 my bid value as high as possible. Why? Because I want to increase my probability of winning this value, unless otherwise I win, then only I will be getting some benefit now, otherwise I will not getting the item only, my benefit will anyway become 0. Even if I have that 50 lakh rupees, it is of no use, I did not get the item of the apartment of my choice. So, therefore, I will be trying to make my bid as high as possible, so that my probability of winning is very high. So, how much I can go? I can go up to my valuation. I have 50 lakh rupees in mind for buying an apartment. So, I cannot go beyond that. So, I will be going up to that. So, in the first case, when V 1 is greater than B 2 in reality, then in order to win, bidder 1 will make B 1 as high as possible, and how much high? When and this B 1 will become V 1. So, he will be bidding, he will be telling his true valuation, and because everybody will be giving true valuation, market will be efficient, the item will go to the highest person. Now, look at the second situation. Second situation is my valuation is less than B 2, which means the other person's bid, my valuation is much lower than the other person's bid. So, if I win by chance, my payoff will actually be negative. So, I will try to decrease my probability of winning. So, how do I do it? I will make this 0, so that my expected payoff 0 and I do not win and end up in getting negative payoff. So, how is it possible? If I make my bid value same as that of my valuation. So, in both the cases, whether my valuation is greater than the other person's bid whether my valuation is less than other person's bid. In both the cases, I am compelled to give my true valuation. This is what I was telling about auction designing the rule of the game, because the rule of the game is the highest person will be getting the item, but with the second highest person's price, this difference that comes up, that compels everybody to pay their declare their true valuation, because they are anyway going to get some benefit, because they are paying the second highest bidder's price. So, such mechanisms are called incentive compatible direct mechanisms. Now, in case of optimal mechanisms, the idea is to increase the expected revenue. This can happen in two ways. Even the efficient auctions can be made optimal by following this. So, here you have to increase the number of bidders, or you can set up a reservation price. If you look at the market, if you look at some study, this is what happens if the number of bidders increase. As the number of bidders increase, the expected revenue keep on increasing, and this becomes stable after some time, depending on the kind of setting you are working. Similarly, if you put a reservation price below which the seller is not willing to sell the item, it will exclude some of the bidders with lower valuation, and the expected revenue increases in the process. So, besides this, you can also think of relaxing the basic assumptions with including the property of risk aversion, then asymmetric valuations, then you can include the reputation effect, how reputed is the bidder in the market, and so on. Then the next one is about interdependencies. We were talking about independent value model so far. Now, it is about interdependencies. Now, in case of interdependencies, as I have told you, the bidder's valuation is affected by knowing the valuation of the other bidder. This in case of a pure common value model, even if I have some initial estimate of the item, price signal from others is going to change it. So, some interesting phenomena happen in case of interdependencies. The English and auction and second price auctions no longer remain equivalent as has been in independent private value setting, IPV setting. Now, these English auctions are likely to yield more revenue than both first and second price auction. Now, this increase in as more information flow, it further increases the value of the object. Another very important phenomena happen here. In this case, if the bidder is not little cautious, he faces a situation called winner's curse, because everybody has almost similar valuation of the object. Just because getting wrong price signal, he will keep on, the prospective winner tries increasing his bid, thinking that probably he is not, he does not have the right estimate, and he ends up finally paying more for an object which he values less. So, this phenomena is called winner's curse. So, these are some of the considerations, economic considerations that happen in the auction. So, we stop here, and next class we are going to talk about an even more interesting phenomena in this auction. Thank you very much.